about GATE engineering mathematics. Okay, engineering maths. You can broadly break up the question paper into three parts. One is general aptitude, one is engineering maths, and another part is your core paper. If you are from CSE, then questions from CSE. If you are from EC, then questions from EC and all that. Okay, which is your core part. So you can divide the question paper into three categories. Total, there will be 65 questions in the question paper, and you will have a 3 hours time to solve the question paper. Okay, so total 65 questions, 3 hour time. 65 questions, total marks will be 100 marks. Okay. Now this is irrespective of whatever stream you come from, does not matter, whatever XYZ stream, this format is same for all. Okay, so 100 marks question paper. Some questions will carry 1 mark, some questions will carry 2 marks. Maximum marks is 2, minimum marks is 1. If the question, now the questions will be of three types. Okay, questions will be of three types: MCQ, MSQ, and NAT. MCQ is just one correct answer. MSQ means the question can have more than one correct answer. NAT is numerical type answer where you have to just input the final answer in the fill in the blanks. So it will be a fill in the blanks kind of question, and you have to write the final answer over there. Okay. Now NAT questions never have negative marking. You can put in any answer. If it is correct, you will get the allotted marks. If it is not correct, no negative marks. MSQ also has no negative marks. If suppose option A and B is correct, you have marked option A and C. There is no partial marking. Okay, since you have got the A option correct, no partial marking. If it is fully correct, then you get the full marks. If any one portion is wrong, you don't get any marks. Okay, so there is no negative marks. But in MCQ, if it is correct, then you get the full marks. If it is wrong, you get a negative marking over there in MCQ. Each of these questions will have a 1 mark question or a 2 marks question. Okay, each of them will have 1 mark, 2 mark, 1 mark, 2 mark, 1 mark, 2 mark, and together it will create 100 marks. Okay. Now you can say general aptitude and engineering maths together. This will comprise of about 28 to 30 marks in the question paper. Okay, 28 to 30 marks will be covered in GA and your engineering maths part. Remaining, you can say the remaining 70 marks will be from your core portion. All right. So this is the overall structure of the GATE exam. Now coming to the syllabus portion, again, whichever stream you come from, XYZ, whichever engineering stream, your engineering maths portion is more or less same. More or less. I'm not saying exactly same, more or less same. Okay. CSE people have one extra portion of graph theory, and they don't have the calculus portion or the numerical analysis portion. The other branches have the numerical portion and don't have the graph portion. So just a little bit change in syllabus. For CSE, something is there, something not there. For the other departments, again, the opposite thing is happening. But you can say 80% of the syllabus is common across all engineering streams for engineering maths. Okay, 80% is common for all. And question level, difficulty level, everything is common. Okay, I am not talking about the core portion. That will keep on changing from stream to stream. Okay, I am not talking about the GA portion right now. Also, I will do that also in this entire series. I'll do the GA portion also because it basically comes under maths only, but I will cover this later. Okay, presently I'm only dealing with the engineering maths portion. Okay. Now there are few more things to tell over here. CSE, as I have seen in the chat that many of you are from CSE. Okay, so CSE has two subdivisions right now. From previous year onwards, all branches of CSE like IoT, then the main core branches, all those are there. So I'll just write CSE core, IoT, all these come under one category, and then again AIML and DS, they come under a separate category. From previous year, question papers are different for the CSE core people, and AIML DS question paper, it has become different from previous year onwards. Okay, so basically from 2024 you will see AIML has a separate question paper, CSE has a separate question paper. Previously AIML people gave the same question paper as CSE core people, but from previous year it has changed. Okay, so you can get the question papers, they are easily available in the internet. And the other streams, every question paper is different for every stream. EC has a separate question paper, civil, mechanical, biotech, chemical, etc., etc. Everyone has separate question papers. Okay, so now this is the entire structure of gate. Okay, now coming to another question, which is for those people who are going to appear for gate for the first time, they have never heard what is gate. Achha. What will you do with the gate score? Okay, now if you look at 2024 gate cutoff, let's for example take the CSE branch. Okay, I am creating the example with CSE branch. For other branches it is more or less same. The cutoff was 27.8. Okay, this is marks, all right. 27.8 marks out of 100. So out of 100 total marks, so if you are scoring 20, if you had scored 28 in the previous year, you would have said that I have qualified gate. Okay, so this was the cutoff for general category. Okay, for the reservations again low cutoff. Achha. So cutoff is very easy to clear. You can see if you just do the engineering maths portion and the general aptitude portion, there only you are scoring 30. So you can just clear the cutoff just by engineering maths and GA. You don't even need to know your core paper. You can clear the cutoff and you can say I am gate qualified. But now if you want to go to higher studies, okay, let's say MTech and PhD. If you want to go into this in the IIT, NIT, IISc, so all these premier institutes, they are going to take admission through your gate score. So if you want to get admission over here, then your score has to be in the range of, I'm talking in scores, okay, your score has to be in the range of 65 plus. When you're close to 65, you will be getting the NITs. You're close to 70s, you'll be getting the IITs. You're close to 75, you're getting the IISc kind of things. Okay, so this is the basic structure that follows. Now this is number one thing, people mainly do gate for MTech, PhD, but lesser known facts are you can directly get interview calls in PSUs. What are PSUs? Public sector undertaking. Okay, government jobs like in IOCL, Indian Oil, BPCL, NTPC, Bharat Petroleum, uh, Indian Power Grid Corporation. Name any PSU undertaking. There are total like 37, 38 PSUs which recruit directly from GATE scores. Okay. Even nowadays, good tech companies, they also prefer a GATE score in the CV of the candidate. Okay, you can check this online. So if you want to get a interview call from the PSUs, your score has to be definitely 70 plus. Okay, out of 100, if your score is 70 plus, you can say that you will be getting some PSU call interviews. You directly go to the interview. If you clear the interview, you get the job. Okay, so I always suggest engineering people give the GATE exam, not for MTech, but for PSU, because ultimately everyone wants a job. At the end of the day, everyone is studying because they want a job. Maybe someone wants to do a higher studies and then go for a job, or someone directly wants to go for a job. End of the day, everyone wants a job. So if you're wanting a job, then this is the best thing that you can get. You can get PSUs. That's the best thing, and you don't have to study more than your syllabus or outside of your syllabus. Everything which you're studying in your engineering, maths, and your core subjects, just direct questions you will get from them. Direct questions. In fact, very easy questions if you just know the basic syllabus. The problem is people cannot remember the 4-year long syllabus. Okay, if you look at your BTech syllabus, it is very vast. From first year to fourth year, let's leave fourth year. First year to third year, 3 years syllabus in one exam. So 3 years of knowledge you have to carry in one exam hall. The question paper will be easy. The problem is keeping the 3 years knowledge in your mind on the exam day. That is the challenge. The question paper will be easy. Okay. If you compare this with joint entrance exam, joint entrance is 100 times tougher than GATE exam. 100 times tougher. Cracking GATE exam is very easy. You just need to keep everything in your mind, be present that day, and you can crack the GATE exam. It's very easy. The problem is people can't keep so much information for 3 years. That's the problem. Okay, and one more thing for people who don't know, if you become a GATE qualified person, your GATE rank will be valid for 3 years. Okay, so you can sit for the GATE exam in your 5th semester, in your 7th semester, and after that you basically pass out from engineering, and after passing out also as a pass out you can go for the exam. But I will always say that 5th semester is the best time for you to give your GATE exam. Best time. Because if you are planning for 7th semester, your engineering maths syllabus ends at 5th semester. Okay. After 5th semester, no stream will have mathematics portion. You will only have your core portions. So your maths ends at 5th semester. So 6th and 7th, 2 semesters, that means 1 year, you are not in touch with mathematics. Your engineering mathematics will fully forget, and you will leave those easy 30 marks, and you can never get a good rank. Okay. So best bet is 5th semester. When you remember all the engineering maths, you are almost done with all the core things, you can go for the exam. 7th semester, the problem is you will know the core portion better, but you will forget the engineering maths. Okay, that is the difficulty. So I always suggest 5th semester should be a target to crack GATE. You cracked on 5th semester, you still have the GATE rank valid for 3 years. You get out of engineering, go for higher studies, or sit for a PSU interview. Simple. Okay, so this is the basic idea behind GATE. I hope I have answered everyone's question. Marks versus rank comparison for CSE, I'm not doing that. These are very easily available in the internet. Okay, you just go in the internet, write 2024 marks versus rank, you will get everything in the internet. Okay, so why waste time with that? Okay, so I hope I have answered the basic questions. So let's start with GATE topic. The topics which everyone has, the common topic. Okay, first we'll be starting with the common topics. Common topics means the topics which each and every GATE stream has this topic. Okay, each and every GATE stream. That is linear algebra. Okay, now at the starting someone was asking me what is the which chapter has the most weightage in GATE engineering maths. This chapter has the highest weightage in engineering maths, linear algebra, highest weightage. You take out any question paper from the engineering maths, you will always get greater than equals to 2 questions from this portion. Okay, 2, 3, sometimes even 4 questions from linear algebra. And specifically AIML and DS, these streams have even more number of questions from linear algebra because their domain is more connected to linear algebra. So they have more questions from linear algebra. Okay. So this is the topic with the highest weightage. Other chapters will have exactly 1 question, but this portion will have 2 or more than 2 questions. Okay. So now let's get started with our topic. Our today's first topic is under linear algebra. We will be only doing the matrix portion today. Okay, very simple, easy topic. Things you have learned in class 11, 12. You have learned in BTech first semester, second semester. You all learned this. Rest things will slowly do it. First, let's focus on matrix. Okay. Achha. So let's start with little bit theory. Okay, I'll not do elaborate theory, it becomes boring. I'll do a little bit of theory and then I will be solving previous year GATE questions. I'll solve 2023-24 CSE questions, ECE questions, civil questions. Okay, I'll solve all of them from this topic. First, let's do a little bit theory. These theories will be directly required while solving the problem. So pay attention to these theories. This is the first one, is the most basic one. Each and every one of you know that matrix multiplication is possible if the column of the first matrix and the number of rows in the second matrix are same. So this has n columns and B has n rows, they are same. That means multiplication is possible, and the after multiplication the order will be m cross p. Okay, so if A has m cross n and B is n cross p, the final order will be m cross p. The basic idea, we all know this. Then this is something we need to keep in mind, that it is not, matrix multiplication is not commutative. A into B is in general not same as B into A. Sometimes it can be same, but not always. Okay. Then matrix multiplication is associative, which means if you interchange the brackets, there is no problem with it, you get the same answer. Okay. Then matrix can be zero divisors. Zero divisors means that if you take product of two matrix and if the value of the product is a zero matrix, it can happen that both A and B are non-zero, still their product is zero. Okay, see, this never happens in real number. If I say x into y is 0, that means either x is 0 or y is 0. So anyone has to be 0 in case of real numbers. But in case of matrix, that is not the same. It may happen that A is also non-zero, B is also non-zero. Still their product is 0. So this property is called zero divisors. You can check for an example. Let's say A matrix is 1 0 0 0. Okay, so this is a non-null matrix. Let's take the B matrix as, let's say, 0 1 0 0, or let's keep the 0 right over here. Okay, so this is also non-null. You take the product of these two matrix, you take the product, you will see you are getting 0 0 0 0. So neither A0 nor B0, still the product is 0. Okay, so matrices can be zero divisors. So this concept you need to keep in your mind. Okay. Okay, moving on to next properties. Types of matrices, you need to remember the names. Okay, because in the questions there will be directly names, that this kind of matrix is given and this is the question, this is what you have to find out. So you need to remember the names of the matrices. Diagonal matrix. Now people have a lot of misunderstanding when we say diagonal matrix. People usually think that diagonal matrix is something like this. Let's say 2 0 0 0 2 0 0 0 2. This is a diagonal matrix. Yes, this is diagonal matrix, but it is not mandatory that all the diagonal elements has to be same. It is not mandatory. They can be different also. Okay, so for example 2 1 0. So this is also a diagonal matrix. Okay, this is also a diagonal matrix. The basic definition of diagonal matrix is, other than the diagonal elements, if the remaining elements are all 0, okay, if the remaining elements on the top and at the bottom are all 0, just leave out the diagonal. Now the diagonals can be 0 also. Okay, see, I have made one diagonal element 0, so diagonal can be 0 also. That is not our concern. Diagonals can be anything. They can be 0, non-zero, same, different, no problem. The elements other than diagonal has to be strictly 0. Then that kind of a matrix is called diagonal matrix. So basically identity matrix is a kind of diagonal matrix. So you can represent it in this way, that all such elements are 0 where I not equals j. See, diagonal elements are generally represented by aii, right? Where I is equals to j, that symbolizes diagonal elements. So when I not equals to j, so we are talking about the remaining elements, they must be 0. This is the property of diagonal matrix. Then upper triangular matrix is, if the portion below the diagonal, okay, this the portion below the diagonal, if that is strictly 0, then we say that this is a upper triangular matrix. Okay, because we have a upper triangle and the below part is 0. So things below the diagonal, if it is 0, that is upper triangular matrix. So the criteria is all such elements are 0 where the index I is greater than j. Okay, so you can see in this portion, your index I is always greater than j in this portion. Okay. Similarly, we will get a lower triangular matrix, just the criteria will be opposite. Okay. So you can see this is a lower triangular matrix. The things above the diagonal are 0. Things above the diagonal are 0. So that is represented by aij equals 0, where I less than j. Okay, simple. Next we have a few important names. These names you need to remember. Okay, these names are important. Idempotent matrix means a matrix such that if a square equals a, okay, if the square of the matrix is equals to itself, it's called idempotent matrix. Involutory matrix, if square of the matrix is equals to identity, identity matrix means diagonal 1 and remaining everything 0, then it is involutory matrix. Nilpotent matrix is if a to the power some integer, okay, k is some positive integer where k is the least positive integer, then k is called the index. That means, for example, let's say if a to the power 5 is 0, okay, or let's take a more easier example, a cube equals to 0, where a square is non-zero, a is also non-zero. For the first time it becomes 0 when the power is 3. Then obviously if I take a whole square both sides, then a to the power 6 will be also 0, but the index is not 6, the index is 3. Okay, it is the least positive integer for which the matrix is becoming 0. So 3 is the least value for which it is 0. So that means 3 is the index and A is a nilpotent matrix of index 3. Okay. Then orthogonal matrix. Achha, remember this. Today only I will do one question from this, one previous year GATE question involving orthogonal matrix. So remember this. Orthogonal matrix is A into A transpose equals to identity. Okay, the multiplication can be opposite also, like it can be A into A transpose also, it can be A transpose into A also, does not matter, the product will be identity. Okay, this is called orthogonal matrix. Remember this will be useful. Okay, then going on to the next property, symmetric matrix. Now we all know symmetric matrix, you have done this in class 11-12. A equals to A transpose symmetric matrix, this we all know, but these are some important things you don't know, you need to remember. This will be helpful for MCQ. If A is symmetric, A to the power n is also symmetric for every natural number. For any higher power of A, it will be symmetric also. So if I say A is symmetric, then I can say that A to the power 100 will be also symmetric. So you don't need to find out A to the power 100. Okay, just by property you can say if A is symmetric, any power of A will be symmetric. Okay, then if A is symmetric, adjoint of A will be also symmetric. Okay, these are important properties. If A is symmetric, A inverse is also symmetric. Okay, inverse matrix is also symmetric, adjoint is also symmetric, any higher power of A is also symmetric. For skew symmetric, there is little bit change. So again, we all know what is skew symmetric. A equals to minus A transpose. Okay, so if A is skew symmetric, now this is important. 2n plus 1, A to the power 2n plus 1. Now 2n plus 1 means odd number, right? 2n plus 1 is odd number. So A to the power any odd number will be skew symmetric, and A to the power 2n, 2n means even number, A to the power 2n will become symmetric. So if A is skew symmetric, A to the power odd number is skew symmetric, A to the power even number becomes symmetric. So little bit change. And also the diagonal elements of a skew symmetric matrix are all 0. This also you should know, you have done this in class 11-12. Diagonal elements of a skew symmetric matrix are always 0. Okay, so these are some important properties of symmetric skew symmetric matrix. Moving on, Hermitian matrix. What is a Hermitian matrix? If A equals to A star. Now what is A star? A star symbolizes A transpose bar. Now what is bar? Bar means conjugate. So what is conjugate? Suppose I have a matrix A, or let's say 2, 1, 0, 1 plus I. Okay, I is complex number I. So what will be A bar? A bar will be the bar of each element. Bar means conjugate. Conjugate of each element. Now conjugate of a real number is the real number itself. So 2 remains 2, 1 remains 1, 0 remains 0. But conjugate of 1 plus I, conjugate of A plus IB is A minus IB. So 1 minus I. Okay, so this is conjugate. So after doing the conjugate, if you take the transpose, then that is called A star. Now if A is equals to A star, then it is Hermitian matrix. Similarly, skew Hermitian if there is a minus sign, A equals to minus A star. Okay, so A star is A conjugate transpose. Unitary matrix is A multiplied with A star equals to identity. It is quite like the orthogonal matrix, right? For orthogonal matrix, it was A transpose equals to identity. For unitary, it is A star equals to identity. And singular matrix, this also everyone should know from class 11, 12. If determinant of a matrix is 0, it is singular matrix. Remember this property. We'll do many problems based on singular matrices. Okay. So these are some basic properties. Achha. Moving on from here, this property though we all know how to find out the inverse of a matrix. A inverse is 1 by determinant A into adjoint A. But this is also something you should know, and this is very important. We will again do problems based on this property. Determinant of adjoint A is determinant of A to the power n minus 1, where n is the order of the matrix. Okay, n is the order of the matrix. So basically, if I say A is A, B, C, D, E, F, G, H, I, okay, then determinant of adjoint A will be determinant of A to the power, this is a 3 cross 3 matrix, so to the power 3 minus 1, that means determinant of A square. Okay, so this is again important property. All right, moving on from here. Achha, now trace of a matrix. We get several questions in GATE from trace. Each and every linear algebra question is generally, one question from linear algebra is always from trace of a matrix. So what is trace of a matrix? It is the sum of the diagonal elements. Okay, so if this is my A matrix, then trace of A is A plus E plus I. The sum of the diagonal elements is called trace of the matrix, represented by TR. Okay, so sum of the diagonal elements of a square matrix, that is called trace of a matrix. The properties are very important. Remember this. At least one question in GATE comes from trace. So if there is a constant multiplied with the matrix, the constant can come outside the trace, no problem. Addition of two, if you are finding the trace of addition of true matrices, then you can do the addition separately, answer will remain same. This one is specifically important. Trace of AB is same as trace of BA. But remember, in general, AB matrix is not same as BA matrix. Okay. These two matrices are different, but the sum of the diagonal elements will remain same, although the matrices are different. Okay. So trace AB and trace BA same. And this is another property. Trace of P transpose AP is same as trace A. That means it is same as the matrix which is right in between these two, P transpose and P. And what is P? P can be any non-singular matrix. Non-singular means whose determinant is non-zero, right? So P can be any non-singular matrix. Does not matter which non-singular matrix. Any non-singular matrix. So trace of P inverse AP will be same as trace of this matrix in right in the middle. Okay. So these are all the important properties we have. Okay. So now we will do some problems. Anyone has any question up till now? Before we start the sample questions, anyone has any questions to ask? You can please ask in the comment. I will wait for 1-2 minutes. All right, no questions. Okay, so let's do some sample questions from previous year. So this is a GATE CSE 2023 question. Okay, CS 2023. Simple determinant question. Class 12 student can also answer this. One A matrix is given, one B matrix is given. you have to tell me what is the relation between the determinant of the two matrices. You don't even need a pen and copy to answer this question. Just look at the question, tell me the option. Okay, I will wait for someone to answer. If I get wrong answers, then I will do the question. Just look at the question and you should get the answer. Pen copy not required. Let's see who can answer this. Just tell me the correct option number. Aditya Nath is saying option A. What about others? Come on, this is very easy. Just look at the question and answer. This is 1 marks question. GATE 2023. Still waiting. Option A. We have got 2 option A's. Let's wait for one more answer. Everyone saying option A. We have got 4 option A's. Let's see. So observe this carefully. 2, 3, 4, 1. 2, 3, 4, 1. So row number 4 is same. Achha. Then 4, 1, 2, 3. 4, 1, 2, 3. Row number 2 is same. But now observe here. This row has come over here and this row has gone over here. So that means there is one interchange of rows. So basically if you interchange these 2 rows, you get the B matrix. If you interchange the 2 rows, you get a B matrix. Now tell me, in determinant, if you interchange one row, what happens? Tell me. If you interchange a row, what happens? Class 12 basic idea, determinants. If you interchange 2 rows in a determinant, what happens to the determinant? Negative sign, correct, negative sign. So that means determinant of A is equals to minus of determinant of B, because there is one row interchange. If you interchange row 1 and row 3, then you will get the B matrix. 1 interchange means 1 minus sign. 2 interchange means 2 minus sign, which will again become plus. So here there is only one interchange. So 1 minus sign. So that means option B. Okay. See, it was so simple. Just little bit observation. Pen and copy was not required. Little bit observation. Everyone gave me wrong answers. Okay. Let's do another question. 2022 GATE CS 2022. If it is not visible over there, I will write it. Here it is written. This is A M cross N. This is B N cross M. Okay. This is C N cross N. This is D N cross N. Then 2 statements are given. See, trace of a matrix. I told you every year one question comes from trace. So statement 1 is saying trace AB and trace BA is same. Statement 2 is saying trace CD and trace DC is same. I have just now taught you property of trace. Tell me what is the correct answer. Come on, this should be a 5-second answer. Correct. Option C. Both statement 1 and 2 are correct. Because just now I told you, if you interchange the multiplication, trace value does not change. So trace is basically commutative. Trace AB, trace BA will be same. Trace CD, trace DC will be same. Does not matter what the matrices are. Okay, so in general, option C is same. Or option C is correct. That means both the statements are correct. Okay. So next question. Now ECE 2023. So first you people try this question. I will give you 1 minute time. Try the question. Then I will answer it for you. Try the question first. Be careful with one thing. This is X transpose X. This is X transpose. Two different things. Okay, two different things. If you multiply transpose first and then the original vector, you get a different answer. You multiply the original vector, then the transpose, different answer. So be careful with that. Let's see who can answer. This question you might feel it is difficult because of n cross 1. So first I want to see whether anyone can answer this. After that I will tell you the easiest way to answer. See, again the question is from trace. Okay, as I was telling you, every year one question from trace is always there. Chalo, tell me. I'm getting option C as one of the answer. Let me wait for a few more answers. Anyone else wants to try? Shayon is saying option C. Aniket is saying option A. Well, if I can recognize you, Aniket, then this is not the class you should be in. You have crossed this stage. Okay. So let's see how this can be done. See, the easiest way I will say is whenever you have a generalized question, okay, n cross 1, generalized, don't keep the question generalized because this is an MCQ question. Answer is in front of you. The challenge is to identify the correct answer. So let's take the help of that. Okay. Whenever you have a generalized question, remember this. We will do this in every chapter, not only in linear algebra. Every instance, whenever you come across something with n, generalized term, don't solve the question with generalized term. Take a very simple value and get the answer. Okay. Let's take n equals to 2. Okay. Now you will say, why not 1? Don't take n equals to 1 because if you take 1, then it becomes 1 cross 1, 1 cross 1. It is not generally a matrix. We don't take it as a matrix. It becomes a single element, right? So don't make it 1 cross 1. Keep it little bit more than that. Again, don't make it 3 cross 1. 3 cross 1 means you will unnecessarily waste more time. Best is take n equals to 2. So that means x is a 2 cross 1 vector. Okay, 2 cross 1 vector. That means 2 rows, 1 column. Okay, that means a vector looking like this. X is a vector looking like this. 2 rows, 1 column. Let's say it is AB. The elements are AB. Okay, let's take it AB. So what will be X transpose? X transpose will be row wise AB. So just converting the column into row. So row wise AB, X transpose. So let's find out the L value. L is root over of X transpose into X. X transpose means row wise AB and X is column wise AB. So if you do basic matrix multiplication, okay, A into A is A square plus B into B square. So your L is how much? Root over A square plus B square. Now you have to find the trace of P. Okay. Now P is X transpose. So X transpose means column wise AB, row wise AB. If you do this multiplication, now this will be a 2 cross 2 matrix. So this will become a 2 cross 2 matrix. If you do the multiplication, A square, A into B, AB, B into A, that is again AB, B into B square. Now you need to find the trace of this matrix. So what is the trace? So if you look right over here, the trace is A square plus B square. So over here, trace of P matrix is A square plus B square, and that is same as L square, right? That is same as L square. So your answer becomes L square, option A. Okay. So just by taking a small example, we have got our answer. Don't try to solve by genuine process. That will require more amount of mathematical computation and higher level of mathematics to prove. So always take simple value of n whenever you have a generalized question. Create your own example. Your answer should match. As simple as that. Okay. Come on, tell me yes or no. Have you understood? Give me a yes or no. Give me a yes or no. Okay. All right. Let's move on to the next question. EC 2016. See again, questions involving trace. Each and every question I'm showing you, it is involving trace. A matrix is given, determinant value is given, trace value is given. You have to find out mod value of A minus B. So trace is given means you know the addition of these elements is how much. Addition of these elements is 14. You know that. Okay. So if you add these elements, how much will you get? A plus 5 plus 2 plus B. That means 7 plus A plus B, and this is equals to how much? This is equals to 14. Right? So 7 plus A plus B is how much? 14. So that means A plus B is how much? 7. Right? Now determinant is 100, so to find out the determinant also. Acha. Now use your brain to find out determinant. Don't start expanding from the first row. Be little careful. You can see many zeros are over here, so take the help of the zero. So if you expand along this last row, then basically you get just the value B. Okay, so basically you are getting B into A03251,002. Again, if you expand along this 2, okay, if you expand along this 2, then 2B times A025, right? Sorry, A025. So now if you break this determinant, how much will you get? 5A. So that means the value of this is becoming 5A into 2B. So that is 10AB, right? The value is becoming 10AB. This is same as 100. Okay, determinant value is 100. So we have that 10AB is equals to 100. That means AB is equals to 10. So you know the value of AB, you know the value of A plus B. You just have to find out A minus B mod. Okay. So we can write A minus B whole square as A plus B whole square minus 4AB. Right? A plus B, I know the value is 7. So this is 7 square minus 4AB. 4AB will be how much? 40. Right? So minus 40. So 49 minus 40, that is 9. So A minus B whole square is 9. So A minus mod A minus B, because if you are doing a root over, you get a plus minus. So mod A minus B will be how much? 3. So this is a numerical type question. As you can see, there is a fill in the blanks. So you have to enter the answer 3. Okay. Right. So moving on to another question. 2028. This is a very simple question. Everyone should answer this. Come on, everyone should answer. Which one of the following is singular? This is like a free question. Free 1 marks. Tell me. Just look and tell me. What is the meaning of singular? Determinant equals 0. So just look and tell me which one has determinant 0. Simple question. So this is option C, 12 minus 12. Done. All right, another question, 2018. So this is a nice question, because if you don't use the property, the question becomes big. See, I told you right at the starting, we will use orthogonal matrix today. This is that question. You will require orthogonal matrix. Okay. So Q is orthogonal matrix. Q is given. You have to find the inverse. That means basically you have to find out Q inverse. Now people who will not know the property, what they will do, they will start finding out the inverse of this matrix. It will take 5-10 minutes time to find the inverse. So obviously there has to be a shortcut. Okay, so we'll do the question in like 30 seconds. So I'll slowly explain it to you. Orthogonal means what? Orthogonal property was Q into Q transpose equals to identity. This was orthogonal. If I multiply both sides with a Q inverse, okay. If I multiply both sides with a Q inverse, so I am left with Q transpose equals to Q inverse, right? Because this Q is becoming identity if I multiply Q inverse. So multiplying Q inverse both sides, I'm getting this. So I can see Q inverse is same as the transpose of the matrix if the matrix is orthogonal. And the question is asking me to find out Q inverse. So basically all I have to find out is Q transpose. So basically I just have to find out Q transpose. So just try to find out this row is present in which column, because I have to do transpose, right? Row will become column. So this row is present in which column? It is not present in this column. It is not present in this column. It is present over here. See, 3 by 7, 2 by 7, 6 by 7, 3 by 7, 2 by 7, 6 by 7. So that means the other rows are also matching. Second row is also matching. Third row is also matching. Option C is correct. Okay. So no need of again pen and paper. If you know orthogonal matrix property, directly by observation you get the answer. Okay. Right. Moving on. Achha. 2021 BT. Determinant of the matrix. You have to find out the determinant of the matrix. So here there is no such shortcut to use. Directly you have to find the determinant. But again, don't start expanding one by one. Let's try to make as many zeros as possible. Then we will find the determinant. So what we can do is like we can use this one to make this position, and this position 0 by doing some row operations, right? So we can do some operation like this, that row 2 dash equals to row 2 plus row 1, row 3 dash equals to row 3 plus row 1, row 4 dash equals to row 4 minus row 1, so that I can make all these elements 0. So if I do this, 1 minus 1 0, this is 2 2 2 0 0 2 2. If I subtract 0 0 0, 3 minus 1 is 2, right? Now again I will use the zeros to find the answer. So let's say if I expand along the first column, then I just have 1 and rest everything is 0. Then next I will expand along this 2. So basically I get something like this. Next, if I expand along this column, again I get 1 2. So all I am getting is product of diagonal. Now this is again a property. If you have a lower triangular or an upper triangular matrix, see, you can observe this is a upper triangular matrix, right? This is the upper triangular matrix because all the elements below this is 0. So remember, if it is an upper triangular matrix or a lower triangular matrix, then the determinant value is equals to product of the diagonals. And you can see it over here also. If you try to expand it, you are only getting the diagonal elements. So the product or the determinant value will be how much? 1 into 2 into 2 into 2. So basically 2 to the power 3, that is 8. So the answer is 8. So from now on, you should not think in this way. You should remember, if it is upper triangular matrix or lower triangular matrix, determinant value is equals to product of the diagonal elements. Okay, if you don't remember, if you try to break it, you'll get the same answer. All right, let's do one more question. Okay, so let's make this the last question for today. As I said, I don't have much time today. So, mechanical 2018. A matrix is given. You have to find out determinant of A inverse. Let's see. Let's let people try first. Then I will tell the answer. Let people try. This is the last question for today. So let's see who can answer it correctly. Yes, 0.25 is correct. I want to know what is the property you are using. Tell me what is the property you are using. 0.25 is the correct answer. Just tell me the property you are using. And meanwhile, Rajdeep, to answer your question, you are saying dimensions are not same. See, it does not matter. In the dimension question, AB trace is equals to trace BA. If the product is possible, okay, if the product AB, BA, if both the products are possible, trace will be equal. Does not matter what is the ultimate dimension after multiplication. Dimension can change, but product will remain same. You can take two examples and check. Provided if the multiplication is defined from both the ways. Okay, so you're saying Rajdeep is saying eigenvalue. I don't want to go to eigenvalue right now. The determinant of A inverse equals to determinant of A whole inverse. Okay. So basically you are using a deduced property. Let me come to how that property we are getting. See, people are saying that determinant of A inverse will be equals to 1 by determinant A. Okay. Now the question is, how is this happening? How? How do we know that determinant of determinant of A inverse is same as 1 by determinant of A? Because these things look different, right? A inverse is a matrix. Determinant of that, how will be equal to 1 by determinant A? This actually comes from this property. If you remember, adjoint of A determinant is determinant A to the power n minus 1. See, I hope you remember this. This is a 3 cross 3 matrix over here. So that means n value is 3. Acha. Now, A inverse, I know it is 1 by determinant A into adjoint of A. Right? This is the basic formula. If I take determinant both sides, I am taking determinant both sides. Now remember one simple property. If I have determinant of K times A, if I want to bring K outside the determinant, then it will come outside. How will it come outside? K to the power the order of the matrix into determinant A. So if you bring out a constant common from determinant, constant to the power order comes out. Basic property. So over here, 1 by determinant A, this is constant. I want to bring this outside the determinant. So that means 1 by determinant A to the power order is 3. This is how it will come outside. And what remains is determinant of adjoint A. Now you already know the formula for determinant of adjoint A. What is the formula? So I have 1 by determinant A whole cube, and determinant of adjoint is determinant A to the power n minus 1. N is how much? 3. So n minus 1 is 2. So to the power 2. Right? So now if you cancel A square and this cube, you are left with 1 by determinant A. So from now on, you can remember this as a property that determinant A inverse is 1 by determinant A. You can remember this as a property. Now, it is very easy to find out determinant. As I told you, this is an upper triangular matrix. If you observe, this is an upper triangular matrix. So that means determinant of A will be equals to product of the diagonals. Product of the diagonals. So product of diagonal will be how much? 1 into 4 into 1? 4. So product of the diagonals is 4. So 1 by 4 is this answer. That means 0.25. 0.25. So the answer is 0.25, correct up to 2 decimal place. That's it. So if you remember this as a property, this is a direct answer. Okay. All right. So we will keep today's class up till here. Again, we will continue from next week. Okay. So thank you for joining online. Bye bye. Good night.